Notifying about unexpected conditions is one of the most valuable activities. It helps to maintain the efficiency of the assets and ensures safe and reliable plant operation. Next to keeping the process running efficiently, you also avoid health risks or monetary penalties. Quality or environmental issues damage your reputation, which came by foot and leaves on horseback. Traditionally, alarm systems were expensive, cluttered, and had a hard time to keep history of the records. Reviewing what happened at night involved a lot of paperwork and would be an issue if the printer ran out of paper. Even in modern alarm systems, we have a common list of issues to be addressed. As this screen shows, the user has a hard time to address the most important issues, because there is too much information and distracting the user from the critical items. Embracing the alarm philosophy, like the ISA 18.2 industry standard, will focus your organization to identify, rationalize, and design the alarm system and to allow efficient monitoring of your assets. You will periodically monitor the results of your initiatives and tune the system to improve these activities. Alarms are classified as digital limit, rate of change, or deviation alarms, and priorities define the importance of each alarm condition. The alarm can be associated with metadata, such as related displays, help instructions, or a maintenance video. Alarms can also be associated to related process values, such as identifying the level in a tank when a pump enters a temperature trip alarm. Alarms are organized in areas and sub-areas to improve filtering and reporting, and to monitor the complete site at one glance, to allow the user to drill down into the area that needs attention. Alarm messages can be language aliased, and then the same alarm will show as Chinese, Swedish, Dutch, or English. Access rights to the users is controlled by a granular security system, where conditions and user actions are protected against unauthorized actors. Also, the interaction with the alarms is recorded and allows for statistical analysis and tracing the activities by the users. To reduce the number of chattering alarms, you specify the deadband. The on-off delay determines if the alarm should be fired even when the condition is only valid for a short time. A cooling door may, for instance, be opened for a few seconds, but staying open longer may have an effect on the temperature and impacts the quality or health of the asset. Expressions can be used to provide logic when an alarm condition is reached. For instance, a closing valve will reduce the flow in a pipe and may not be an alarm when the valve is intentionally closed. Also, alarm settings for each alarm can be assigned a static value or dictated by a dynamic changing data source. The user can filter and group alarms, which is specifically useful to analyze all alarms for today or this week. Active alarms may be shelved if they do not need immediate attention. Each alarm may have attributes such as the timestamp, tag name, message, or process value, and the user that designs your alarm dashboard will decide together with you which attributes are relevant to see in any dashboard. Historical records typically contain more attributes to allow detailed analysis at a later moment. Alarm conditions are color-coded and can be changed to meet your company standards. In addition, the color coding of alarms in a certain priority range can be defined to have a variation on the alarm color being used. This would show immediately the user, by just looking at the color, the importance of the issue. The alarm dashboard can filter alarms and alarm history for specific working shifts. The number of shifts and the start and end condition of each shift would be defined by the user. To interact with the alarm, the user would typically view the alarm and acknowledge the alarm and enters a comment when needed. When alarms need to be addressed later, they can be shelved, latched, or suppressed. When you see many alarms, you can shelve the less important alarms in order to focus on the alarms that need immediate attention. The shelved alarms can be configured to unshelve automatically after a specified time. When the alarm is set in the out of service state, it will not generate alarms until the state is reset by the user. The user can set the alarm in the suppressed by design state and reset the state at a later time. The user may also acknowledge an alarm too soon without resolving the conditions that caused the alarm. Alarms that use the re-alarm setting will automatically return to the unacknowledged state after a configurable time if the alarm has not returned to normal yet. This ensures that the user will again be confronted with the issue and not forget the issue. The latch state is used to keep the alarm visible even if it returns to the normal state and has been acknowledged by the user. The user could reset the state when the alarm is at rest in the field and no longer needs to be latched. The user can filter subsets of alarms and group alarms based on attributes such as the type of alarm, high, low, digital, or the priority of the alarm, matching all the same priorities. Results of what the user sees can be quickly exported to Excel, CSV, or HTML format when needed. When certain criteria are met, alarms can be sent to users via email or SMS. Windows 10 devices can be used to benefit from the push notification in the mobile HMI app. Users may open the web browser and use the AlarmWorx application to create a dashboard to monitor active alarms, perform statistical analysis on the alarm history, and present data exposed by other databases and other real-time data sources when needed.